Morning, sir.
Yeah, yeah, good morning. So in the previous class, we have been discussing on the root stability, root locus and root stability criteria. So to measure the stability, whether it is the system is stable, unstable or marginally stable. So we have understood how the terms, all this B1, B3, C1, C3 and all these things are coming. So all of you might have completed till there. So now we will see few limitations of that. So the limitations of roots criteria does not give the location of the roots that lie to the right half of S plane. So that is one of the limitation. The in the roots criteria does not give the location of the roots that lie to the right. Show you that the location of the roots which is lying right half of the S plane and does not tell whether the roots are real or complex. So this also it is one of the limitations of the roots criteria. So these all things you may have to write when the root stability criteria is asked for you to explain. Then and the next point is roots criteria cannot be applied to any other stability boundaries in the complex plane. So these are some of the two limitations which you can see. So the roots criterion cannot be applied to any other stability boundaries in a complex plane. And the first one is roots criteria does not give the location of the roots that lie into the right half of S plane, and also does not tell whether the roots are real or complex. So you can note down these limitations. So after that, we will be seeing that relative stability analysis, and we will try to understand more on the root stability criteria. So the relative stability analysis we will see now for the roots criteria, roots stability criteria. So there are few conditions and all. So we are going to see that to check the relative stability of the system, S plane axis. To check the relative stability of the system is to shift the S plane axis and then apply the roots criterion. This is to put S is equal to S1 minus infinity, where infinity is a constant into the characteristic, or alpha you can put, sorry, S is equal to S1 plus S1 minus alpha, where alpha is a constant into the characteristic equation. So this is what you can say to check the stability. So to check the stability of a system is to shift the S-plane axis and then apply the roots criteria. So we put S is equal to S1 minus alpha, where alpha is a constant into the characteristic equation. What is that characteristic equation? You have already seen S to the power of 5 plus S to the power of 4, etc. like that is equal to 0. We have already defined as an example there. S is equal to S1 minus alpha, where alpha is a constant into the characteristic equation of the system. So we are going to shift the S-plane axis by introducing S is equal to S1 minus alpha. Now to get the polynomial in terms of S1, and by applying the roots criteria to the new polynomial in S1. So we are going to see that these are a few things what you have to understand. Now we get the polynomial. When we introduce S is equal to S1 minus alpha, we will come to know that your equation will slightly get modified in terms of S1, and then you can apply the roots criteria to the new polynomial in S1. So some of the methods are there where your this criteria has to be modified by substituting S is equal to S1 minus alpha, and the equation will means equation will get in the form of S1. The entire equation will come in the form of S1, and then you can simplify it further. So you can just note down these points, relative stability analysis, more on the root stability criteria. So we will be seeing with examples and all. So as we have been, I have mentioned you before that the sign change is very important in the root stability. So that's what we are going to do. The number of sign change in the first column. So how many sign change is available in the first column of the roots array using the new polynomial is what is equal to the, so we are going to see that. So is equal to the number of roots that are situated in the right of the vertical. So this all we are going to see with some examples. So how the when the roots are placed and how to find out whether the stability of the system is there. Thus the number of roots that lie to the right of the vertical line is also found. So you can see that I will just go back. You can take down these things. I will explain you this once again. So what you can see here is you have a characteristic equation like s raised to n plus s raised to n minus 1, etc. Is a is equal to 0, a naught is equal to 0. So that characteristic equation, if you want to, if this you are not able to find out the whether the stability of the system is proper, or you are not able to find out the stability of the system by root stability criteria, then you may be trying to shift the s-plane axis by substituting s is equal to s1 minus alpha. Alpha will be a constant, and we'll be substituting that s is equal to s1 minus alpha. So the entire characteristic equation remodify itself in the form of s1. So once the equation remodifies in the form, it will be a new, entirely a new equation in the in S1. So once you get that, you then again use the roots criteria and try to simplify it. So after doing that, you will check that the first column. So I have we have already discussed these things before. So this is the first column, this column, first column. You'll be seeing that is there any sign change? Like here it will be plus, here it will be minus. So there will be a sign change. So for example, this is plus and this is minus, and again this is plus. So what you can see is there will be a sign change in the constant. So all those things we are going to discuss further. When you do some examples and all, it will be more clear for you. So you can note down these things, and then we will move on to further explanation. Have you completed? Have you completed these things?
Yes, sir.
Yes, yes, sir.
So this is okay. Thank you. So we are going to just proceed further. So these are a few things which you have to understand here. The main thing is that you are trying to substitute S is equal to S1 minus alpha and changing the characteristic equation by introducing the constant alpha. Okay. So so we will see further. So the number of roots that are situated to the right of the vertical that is S is equal to minus alpha, thus the number of roots that lie to the right of the vertical S plane is found. So this is the few more lines you can add on. So now we will go with the one of the example where you are going to use one equation and you are going to try it with Routh's stability criteria methods, whatever you have learned now. So investigate the stability uh, solving the problem. You should write as a conclusion that the system is stable, or you should write that the system is unstable, or you have to write the system is marginally stable. So that is the answer for this problem. Just solving the problem is not enough for this. If you say that you solve the problem, you don't write that whether the system is stable, unstable, or marginally stable, you are going to lose marks for that. So if it is 10 marks, even though you have done everything and you have not done the analysis that whether the system is stable or unstable or marginally stable, then to get rejected for it will be reduced, because you don't know that whether after doing the problem whether the system is stable or not. So it's very important to find out the stability of the system. So we are doing this to find out the stability of a closed loop system whose characteristic equation is given by this is one of the problems. So you can say note down this problem, that is s to the power of 5 plus 3 s to the power of 4 plus 7 s cube plus 20 s square plus 6s plus 15 is equal to 0. So you try to, we have drawn the boxes and all those things. So what you have to write first, s to the power of 5, then s to the power of 4, s to the power of 3, s square, s, and s to the power of 0. So that is what you have to write first in the first column. After writing that, you have to write a naught, down it will be a3, a4, down it will be a5. So that is what you have to do. So here you know that the coefficients are already there, 1, 3, 7, 20, 6 and 15. So it's very easy. You can just write down one down to down. Write the column s to the power of 5, s raised to 4, s cube, s square, s, and s to the power of 0. After that, draw that box, everything how you have done in the when I taught you the root stability criteria. It's very easy problem. Don't make mistake in solving it. That is the only thing. Everyone can get full marks in this. There will be two conditions which you will be studying further. Sometimes you will see that zeros will appear. So what you have to do, the entire row becomes 0. So those cases, what you have to do, we'll be studying further. So it's quite interesting to put it in the box and application, and so you have to find out B1 and B3, then you have to proceed further. So I want to know from you, what are the when you do that, what is B1 and what is B3, all those things you find out and let me know. So first thing, you have to write s now, s raised to 5, s raised to 4, s cube, s3, like that down. Then you can see that 1 I have written, next coefficient 3 I will write it down, 7 I have written, next I will write it to 20, I will write it down, 6 I have written, 15 I will write it down. So that is how you have to arrange the coefficients. Then how to find out B3 uh, down, that coefficient, how to find out? You have to multiply 3 into 7 minus 20 into 1 divided by 3. What is the answer for that?
B1 is 1 by 3, sir.
Okay.
And B3 is 1.
Okay, let us see that. Yeah, 1 by 3 and 1. Correct answer. So
C1
you can just proceed further. Yeah,
C1 is 11.
yeah. You complete it. Okay, I will come to you. Just what you have to do, all of you, you can see here. All of you can see here. You have to multiply 3 into 7 minus 1 into 20 divided by 3. Next, 3 into 6 minus 1 into 15 divided by 3. You will get these answers. Yeah, next answer.
C1 is 11.
Okay,
C3 is 15.
okay, correct. So you will get C1 and C3. So everything, since it is the first problem, I have written here how this coefficients has, how this values it has been arrived at. So as we have studied in the previous class, this is what the all logic is. It's a very easy thing for you to understand. All these things is what you are going to get. You have also written the equations here, B1, B3, C1, C3, and all those things. So it is not so difficult. So you will get 1 by 3, 1, 11, and 15. All of you got it till here? What about others? Everyone of you have completed?
Yes, sir.
Okay, fine. So what is that next value you are going to get?
6 by 11.
Next value is 6 by 11, correct? And what is the next further?
15.
15. So you can see that you have done all these things, all each how 1 by 3 is coming, 3 into 7 minus 1 into 20 divided by 3, how 1 is coming is 3 into 6 minus 1 into 15 divided by 3. All those things I have explained you already. So similarly, how 11 will come. So you have to do, this as 1 by 3 into 20 and minus 3 into 1 divided by 1 by 3. How 15 will come? 1 by 3 into 15 minus 3 into 0 divided by 1 by 3. So how 1 by 6 by 11 will be appearing there? 11 into 1 minus. So all these values you will get. 11 into 1 minus 1 by 3 into 15 divided by 11. So all these values you will get. You can get all these things. So it is not completed. We have just found this table, but we have not concluded whether the system is stable or not. So that is the answer for that. So all of you have to complete this and check whether the system is stable or not. So how to check the system is stable or not? You have to check this column. This entire column you need to check. Okay. So you need to check that whether there is a sign change. You can see that all the numbers are positive. There is no minus number or minus plus is not coming. Like here, if it is minus or here it is plus, like that it is not appearing. All the numbers are positive. So when all the numbers of that column are positive, what is the system? Any one of you? We have discussed in the previous class. Yeah, what is that? The system is
Unstable, sir.
when all the numbers are positive, when there is a negative sign appearing here and there is a change of sign, you can say that it is unstable. But when all the numbers are positive, there is no sign change, you can say that the system is stable. Okay. So this is the first problem. So you will understand those things once we do more number of problems. So the system, there is no sign change. in the first column, the root array, and there are no roots, the positive real parts, the system is stable. So that is very important for you to understand here. That is the conclusion here. That is, you have to check the first column, and if there is any sign change, all the numbers are positive, then the system is said to be stable. So you can complete it. There are no sign change in the first column of the roots array, and so there are no roots with positive real system. The system is stable. Is that clear for all of you?
Yes, sir.
Yes, sir.
Okay, fine. So all of you have completed this problem. Shall we move on to the next one? What about other students? All of you have completed?
Yes, sir.
Yes, sir.
Okay, fine. So we will proceed further. So you can write down the system is stable. You just write down the statement. Similarly, you have to write when you are completing when you will do for the exams also. You have to write whether the system is stable, unstable, or marginally stable. That is the answer for this problem. Okay. So the next problem, investigate the stability of a closed loop system whose characteristic equation is given by s to the power of 4 2s cube 3s square plus 8s plus 2 is equal to 0. So you need to find out the stability. So the same way, same method, you arrange the coefficients and all. So s to the power of 4, s cube, s square, s and s to the power of 0. So you write it in the first column. Then you arrange the coefficients 1. Then down to that you can write 2. Then again 3. Then down to that you can write 8. And then again 2. Now you can simplify it. It's very easy to do it. You can just do the multiplication and you can divide by. So you have to do it 2 into 3 minus 8 into 1 divided by 2. You will get the first coefficient, first number. See, all the recordings are available for you. You can just go through it. If you have any confusion, you can discuss with me and get those things cleared. Okay. So all of you try to solve it and tell me that whether the system is stable, unstable, or marginally stable. You have to see the first column and see whether there is any sign change. If there is no sign change, the system will be stable.
Unstable system, sir.
Why? What are the coefficients? You have completed the problem?
Yes, sir.
Okay, let me know the numbers now here.
A1 equals 2, A3 equals 8.
First one.
Okay, sir.
1, 3, 2, 2, 2, 8.
B1 equals minus 1. B3 equals 2.
Okay.
C1 equals 12.
12. Okay.
C3 is 0.
0. Okay. That is not 0. You leave it off.
Okay, sir. D1 equals 2.
2. Okay. So you got this, right? So you can see that there is a -1 appearing. So what you can see here, this is plus, this is minus. So this is minus and this is again plus. So what you can see here, there is a changeover in the sign. So that is what you can observe here. So we can see that whether the system is stable or unstable. So all of you complete this problem. All of you find out these things. So there are two sign change, that is, you can see here there are two sign change, plus to minus. I have clearly drawn here, and minus to plus in the first column. This is very important. You should see okay, first column of the array. This implies that there are two roots with positive real parts, hence the system is unstable. You can write it in this way elaborately. At least the word unstable has to be there. You have to find out whether the system is stable or unstable. So all of you note down that means complete that, and write down this statement and say that the system is unstable because there is a sign change. Okay, that is very important for you to understand. The previous problem, all the numbers were positive in the first column. So there was no change of sign. So it was a stable system. In the second problem, you have got a -1 over there. And so there is a sign change from plus to minus and minus to plus. So what you can say that this implies that there are two roots with positive real parts, hence the system is unstable. All of you have completed?
Yes, sir.
Okay. So we will just proceed further with some notes and so it will not be the case always. So there are some cases, some different case will come, like sometimes what will happen is when you solve it, no, this side, these two numbers, when you solve, both will become zero. The entire row will become zero. So once the entire row becomes zero, it is very difficult to solve it further. So there are different methods to do those cases. So we are going to see those things further. So this note you can write it down there. The entries in any row can be multiplied or divided by a positive constant without affecting the sign change in the first column. So this also you can have a note of it. So entries in any can be multiplied or divided without affecting the sign change. Okay, that is very important because here the sign change is that we are going to find whether the system is stable or unstable. So that's very important. So note what you can write is, if you want to the entries in any row, if you want to multiply or divide by a positive constant, no problem, but you should make sure that the sign change should not be there without affecting sign change in the first column. So this is very important. If you are asked to explain the root stability criteria and all those things, you should also explain the difficulties in roots criteria. So this also should be there in your answer. So once again, I am repeating it. If it is asked in the university question paper or in internal question paper, explain the roots criteria, then you should also you should first explain all these things. Uh, you can see that you have to explain all this, whatever you have learned from here, all these things you have to explain. Then you have to explain with this one, a general case you have to explain. You have to say that how B1 and B3, C1, C3 are obtained. You have to write the limitations. After writing the limitations, you have to write how the S plane can be shifted. after that, these are the problems. If you are not writing the problems, not an issue. These two are the problems, but difficulties also you have to mention in your answer. If a theory question comes for explaining the roots criteria, so you have to take an example and explain the difficulties. There are two difficulties, difficulty 1 and 2, both you have to explain. So it will be a little bit there for you to write. If it is asked, all these things has to be explained properly. Otherwise, in the question itself, if it is not mentioned, means you have to write everything, including the difficulties. If it is mentioned that explain one of the difficulty, means any one, it is enough to explain. So, but make sure that when you're writing, don't miss the difficulties also to include when you are writing the theory question. So, so that is what we are going to see now. Difficulties in roots criteria. So two difficulties are there. The first element, so this is the first element in any one row is 0, but the others are not. So this is what we are going to see, that the first element in any one row is 0, but others are not. So if you are taking that, this you have seen, s to the power of 4, it is continuous, 4, 3, 2, 1 and 0. So it is not necessary that you should have a term like 3s square in between here. It can be s to the power of 4, s to the power of 3, 8s plus 2 also is possible by just so those conditions where the one of the term will be 0. So that is what we are going to see. The first element in any one row is 0, but the others are not. So we are going to see that. So all of you just note down difficulties, mark it as very important. If question come from root criteria, it comes mainly on the difficulties, because students always put it in the halfway, zeros come, they don't know this concept, they have to leave the problem. So you should understand what are the difficulties of roots criteria. Two difficulties are there. First, we'll see that first one is the first element in any one row is 0, but the others are not. So have you completed till here? So it will be clear when we explain with an example. Have you completed?
Yes, sir.
Okay. So let us proceed further. So what you can see here is first difficulty is one of the coefficient is 0. So that is what you can see here. If you are taking, I am just saying that there is if 3s square is not available, so how it will look like. Okay, so let us see that. So the second that we will be discussing, that as the first difficulty. Second difficulty is all the elements in one row of roots array are 0. So what will happen, as I have told you, all the elements in one row will of the roots array are 0. So what will happen is all the elements. So what you can see here is in the first difficulty, I will just take you through the example. In the first difficulty, you can see that you have 1 0 appearing in here. Then when you see here a 0 here, you can say that it is difficulty 1. But in difficulty 2, what you can see here is you can see that we'll be seeing that further. One of the example I will take it for you. So difficulty 2, you can see that both the things are, so the entire row becomes 0. You cannot proceed further with this roots array process. So you have to use a different methodology to do that. So that is what we are going to see. This is both the cases. So the first difficulty you have seen, and the second difficulty is all the elements in one row of roots array are 0. So the entire row becomes 0. Then also you can say that it is solved by using a particular method. So first one is what you can see here. first difficulty is first element in any one row. It can be any one row, okay? Any one row is 0, but the other are not. So you can see that here this one element becomes 0 here. In the other case, you can see that both the entire row becomes 0. So these are the two difficulties. So you can just note down these two difficulties. So second one is all the elements in the first row of roots array are 0. So we are going to see the difficulty 1 and difficulty 2. So write down difficulty 1, write it down properly, difficulty 1. So let us take this problem, investigate the stability of a, so this is an example, or you can say it is a problem. So investigate the stability of a closed loop system whose characteristic equation is given by this one. So we are going to understand the first difficulty. So you can see that once you're taking this problem, you write 1, 2, 3, 1, 1, 2, 2, 3, 5, and all. See here, the coefficients are 1, 1, 2, 2, 3, and 5. You arrange the coefficients. Then, as usual, you start the simplification 1 into 2 minus 1 into 2 divided by 1. You get it as 0. So first itself you understood that whether it is difficulty 1 or difficulty 2, not clear yet. So you got a 0 here. You understood you have to go with either difficulty 1 or difficulty 2. Then again you proceeded with that. You got minus 2 here. So you understood you have to go ahead with the first difficulty 1. If both were 0, 0 here, again in place of minus 2 also it was 0, then you had to go with difficulty number 2. So write down this problem, draw this everything, and then we will proceed and try to complete this difficulty 1 today. So you have written all those things, write down properly difficulty 1. So I am saying you, if it is theory question is asked on roots criteria also, roots stability criteria, you have to write the difficulty 1 and difficulty 2 both. You have to write both difficulty 1 and difficulty 2 along with that theory question for roots stability. So assignment is also given for you. There is only few 2 to 3 problems and 1 or 2 theory questions. So you can just go through that. All those things you can try solving it. It's on the root stability criteria. You understand this? I have sent you all these notes. You can go through it. So all of you have completed this?
Yes, sir.
Okay, so you got here 0. So you are not able to proceed further. So then you call it as a difficulty 1 process. So in difficulty 1 is how it can be addressed as a first element of the row becomes being 0. So one of the element is becoming 0. This is very important. To overcome the difficulty, so what you have to do is you have to substitute S is equal to 1 by Z. So let us go back, and so S is here. No, in place of S you need to substitute 1 by Z. So let us substitute 1 by Z for the characteristic equation. So it will be 1 by Z raised to 5. So how you will write 1 by Z raised to 5, 1 by Z raised to 4, 2 into 1 by Z raised to 3, 2 into 1 by Z raised square, 3, 1 by Z plus 5 is equal to 0. So you are going to substitute in place of S as 1 by Z. All of you do it fast. So you'll get this equation. Then what we are going to do, I am going to multiply by Z to the power of 5. So what you'll get, the equation you will get it as in this form. 5. This is a method of solving it for how, if a difficulty 1 appears, how to solve it. So you have to substitute S is equal to 1 by Z and try to solve it. So you'll get 5s Z raised to 5 plus 3Z raised to 4 plus 2Z cube plus 2Z square plus Z plus 1. Again, you need to write it in this form itself. So you have to draw the column, you have to write rows and columns, and you have to write z raised to 5, z raised to 4, z raised to 3, etc. So you have to write it down. Okay, then you write down the coefficients further. So what are the coefficients here? 5, down to that 3, 2, down to that 2, and 1 and 1. Again, do the root stability criteria itself. So that is 3 into 2 minus 5 into 2. So you'll get minus 4 by 3. Then you'll get minus 2 by 3. You can keep doing it. So you will keep doing it. You'll be getting 1 by 2, 1 and 2. And then further 1. So you complete that. So the main thing what you have to understand here is when the difficulty 1 is to be addressed, you have to substitute S is equal to 1 by Z. So when you write in this difficulty 1, so you can give a small this example and you can show that what is difficulty 1. Even if it is a theory question, you need to write the example and show the difficulty 1. Similarly, how to solve the difficulty 2 also you need to explain it. Then only that theory question will get completed. What is the first coefficient you got? Minus 1 by, you got it? Minus 4 by 3 you got?
Yes, sir.
Okay, complete it. What is the next coefficient? Minus 4 by 3 you got, minus 2 by 3 you got. What is the next one?
Minus 1 by 2.
Minus 1 by 2. Further?
Minus 1.
Minus 1 by 2 or 1 by 2 it is?
One by 2, sir.
1 by 2. So it is 1 by 2 and 1. Further?
Doing, sir.
So anyone of you got the next coefficient? Next value.
Minus 10 by 3.
Minus 10 by, no, it is 2 you will get. What you have to do? 1 by 2 into minus 2 by 3. So 2 will get cancelled, minus 1 by 3. Minus of minus plus 4 by 3. So what you will get?
Two will get, sir.
Yeah, divided by 2 you will get. This and all you can do it the mind calculation, but I will say that you can use calculator because sometimes you make mistake. Don't make mistakes. If you are so next we'll get it as 1. 2 into 1 divided by 2. 1 by 2 into 0. So you'll get it as 1. All of you completed it. So what you can understand here, whether the system is stable or unstable, what is that? Here there is minus. So there is a sign change. So whether the system is stable or unstable?
Unstable, sir.
Unstable. So let us see that. So there are two sign change in the first column. So that there are two roots with positive real parts. So the system is unstable. There are two sign change in the first column, and there are two roots with positive real parts. So the system is unstable. So once you understood these things, it is very easy to explain all these things. So all of you might have completed. So sometimes what will happen is this method may not work to overcome the difficulty. So that is also there. Sometimes this method may not be applicable to overcome the difficulty one. So you have to use another method. If this is also not working out for you, then you have to use another method by multiplying the given equation by s plus 1. You have to use this method. So and repeat the roots criteria. So what you can see, if this method is not applicable, it's also not working out fine for you. So you have to multiply the characteristic equation with s plus 1. So s plus 1 into s to the power of 5 plus s to the power of 4 plus 2s cube plus 2s square plus 3s plus 5. So you have to multiply this equation with s plus 1. So this is also part of it. If this method is not working in difficulty 1, you should go with the method of multiplying with s plus 1. So you can rewrite the equation in this form. You will get the equation in this form: s to the power of 6 plus 2s raised to 5 plus 3s raised to 4 plus 4s cube plus 5s square plus 8s plus 5 is equal to 0, and you can solve it. So all of you can complete it till here, including the solution. So write it all these things and simplify it further. So here also you can see that there is a sign change. So the system is unstable. So these are two methods. Either you substitute s is equal to 1 by z, or substitute or put s plus 1 and multiply the entire equation with s plus 1. So you can try. If the first one is not working out for you in the difficulty 1, then you can use this process to solve the difficulty 1. That is by multiplying s plus 1 for the entire equation. So this is what it is all about. So we will stop it with this. All of you can solve this and complete it. All of you complete it straight away. And once you complete it, you can leave the meeting. Okay. Thank you. So we'll wind up for today. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.